Today we're going to look at finding slope and look at what that means, not just for slope, but how to find other parts of the equation that you're going to be looking for. And the other important part is the y-intercept and other points that you may find on a line. So as we look at these different graphs, we can see that they're crossing the y-axis in different places, they're going through different points, and we're going to learn how to determine those today from graphs. So as you see, I've already got our points plotted for number 1 here, and I've drawn my line. And letter B asks us, as the x values increase, what happens to the y values? So if I look at the points that I've got, and I try to make some kind of determination, well, my x value increases. It goes from -1 here to 2 here. My y values are decreasing. So I can say they decrease. They decrease. So we need to find the slope of the line. Do you remember how we did this before? Well, we did it like this. We started on the left, and to get to the next point I needed to go down 3. So I'd do -3, and then I would go right 3, and -3 divided by 3 is a -1. So my slope is -1. Now it asked me to find 3 other points. When it asks for points, what we're looking for specifically is where this graph, this line, cuts through exactly the corner of a box created by our grid. So here's a corner of a box right there, and here's a corner of a box right there, and here's a corner of a box right there, and here's a corner of a box right there. And I can name those points. The first point we were given -1, 5, these right here. This is point 0,4. As you can see, I've got 0,4. 1, 3, or excuse me, 2, 2, 2, 2. There's 2, 2. Here is 1, 3, and then 3, 1. So I can fill out other values. We're not looking for points that are not in the corner of one of these boxes. We're looking at, so if I have these lines, if you see up here in the top right, where they're crossing, what I want is I want to find where that goes right through in a corner point like that up there. Okay? So the next question is, does the pattern in my table confirm the slope I calculated in part C? So let's look at this. From -1 to 0 is +1, and from this 5 to 4 is -1. And so remember, we put our y change in y over our change in x, and I get a -1 over 1, and that gives me a slope of -1. So yes. So F, it says use the graph or the table to find the y-intercept of the line. So if I'm looking on my table, I'm looking where my x equals 0. I can find x equals 0 right there, and my y equals 4. Okay. Number 2, I've already plotted the points and drawn my line. In fact, I've already filled in my values down here. But it says as the x values increase, what happened to the y values? So if I go from here and I just go over, let's just say I want to go over 1 on my x. Well, if I look at that. I've got a y value that has gone up. So it is increasing. So the y values increase. So I need to find the slope of my line. Well, I can use this point. Since I've already found this one, I can use that one. it doesn't really matter, but I can do this. I can go all the way up to this other point since I have it. So if I want to start here, and I'm going to go up, make sure that line's good and solid so you can see it. I go up 1, 2, 3, 4, 5, 6. So that's positive 6, and then I'm going 1, 2, 3, and I move 3 to the right. Positive 6 divided by 3 is 2. So the slope of the line is 2. So mark and label 3 other points on the line, record the x and the y values. So I could put this point here, that's negative 2, 5. I already have the negative 1, 3. Let's do 1, 1. There we go. And 2, 3. That's the one they gave us right there. And then 3, 5. And notice those are all points where they go right through the corner of a box. Well, I didn't pick... Oh, let me go back. How does the pattern in your table confirm the slope you calculated in Part C? Well, or does it confirm? Yes. As x values increase, so negative 2, negative 1, 1, 2, 3. What's happening? Negative 5 to negative 3 to 1 to 3 to 5. The y values increase. So now it says, use the graph or the table to find the y-intercept of the line. Well, we know x is going to have to be 0, but look at this. We don't have this in our table. So what we need to do is we need to go to our graph, and we're going to find where x equals 0, that is the y-axis. And I need to find this point right here. That point right there is 0, negative 1. 0, negative 1. It's right where it crosses that y-axis. So I can come in here, 0, negative 1. All right, number 3 is a little different. I've plotted the points and I've drawn the line. And let me take care of this right here. Apparently those are the ones that mysteriously jumped from before. So it says, plot the points on the coordinate grid, draw the line, it passes through them, that's done. As the x values increase, so as I go from here to here, does it go up or down at all? Well, it doesn't go down at all. So I would say the y values do not increase or decrease. Find the slope of the line. Well, this is kind of interesting. So if I figure to go from this point here on the left to this point on the right, I do not go up any at all, but I go to the right 2. 0 divided by 2 is 0. And my next point, D, mark and label 3 other points on the line, record the x and the y values. So let's see, 1, 2, 3, 4, 5. The points that I chose, and I picked more than 3. I just wanted to show you here. So I've got all those. It says, does the pattern in your table confirm the slope you calculated in Part C? I go up 1, I go to the right 1, and then 0. So I don't add or subtract anything. And then I put my y over my x, 0 over 1. That is still 0. Yes. So my answer here would be that the pattern in the table, it confirms because my y values do not change when my x values increase. So use the graph or the table to find the y-intercept of the line. I do not have an x equals 0 on my table, so what I have to do is I have to find where that would be. And I know my x value is going to be 0. And let's see. Well, where my x value is 0, that's this point right here. And it looks like that is 0, 4. 0, 4. Notice that is the point where our graph, this red line is the graph, crosses the y-axis. That's this vertical line that we always label y. Where does it cross it? What is that point right there? The big black point is 0, 4. Number 4. How can you use the slope of a line to determine whether the line slants upward from right to left? Let's make that left to right. Left to right. Well, let's see. Whether the line slants upward from right to left, slants downward from left to right. Yeah, let's go back and change this, and we're going to make this left to right. There we go. Is vertical or horizontal? So what I've done here is if your slope is positive, it will slant upward. If your slope is negative, and when I'm talking about slope, I'm talking about the m value. The m value that's this one right here, the coefficient of x. So if the coefficient of x is positive, it will go up. If the coefficient of x is negative, it will go down. If there is no x, or if there is a 0, then it'll have a horizontal slope. Now the last one that we need to look at, and I've drawn the line and plotted the points. I want you to notice that this would not be a function. You see, here is a vertical line, and I have 2 points lying on that same vertical line, so it does not pass the vertical line test, so it could not be a function. So it says plot the points, draw the line, find the slope. Well, I want to tell you right here, this is very important, this is undefined. Because if we looked at this very carefully, we would see that my x value, let's say from here to here, increases by 3. My y value does not change. Well, here's a problem with this. This is mathematically not possible. We can never divide by 0. Never divide by 0. All right? So we can't do this. We can never divide by 0. This is what we call undefined. Do not make the mistake and call this 0 slope. 0 is actually a number. This is not. This is undefined. It is not a function. Other points on the line might be here, 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 here. Okay? Have fun.